For each of the problems in this series, we're going to do two things. First, we'll create a proportion table, and then we'll look at a graph of the relationship, and in each case identify the slope and the y-intercept and interpret what they mean. The point here is to really help students understand how the slope and the y-intercept are related to the idea of proportions. So the first problem we'll look at is if the school makes $1.25 on every raffle ticket sold, how much will it make when 213 tickets are sold? This is a 6th grade standard, and you'll see that it's fairly straightforward. We begin with our proportion table. When students write these tables, please be sure to insist that they put clear headers above each one of their columns, including the units. So tickets sold here implies number of tickets. They could even be more specific and put number of tickets sold, but we know what's in this column, and money made is dollars. Generally speaking, we put the independent variable, the x variable, the horizontal variable, in the first column, and the y variable in the second column, the dependent or vertical axis variable. That's not crucial. There's no law that says we have to do it that way, but if we're consistent, then students will tend to get in the habit of doing it. Okay, so we start off with one ticket. We sell one ticket, we get $1.25. That's pretty straightforward. If we sell two tickets, most students will recognize that we get $2.50. Now, they may come about this two different ways. Some students will just add $1.25 to the first $1.25 and get $2.50. When we go to $3.50 or three tickets, they may add $1.25 to $2.50 to get $3.75, and so forth. 4 tickets is $5. But if they're going to use that approach and try to get to 213 tickets, it's going to take them an awful long time to add $1.25 to these numbers successively 213 times and not make a mistake. So it's really important to help them see that an alternative way and a more powerful way, using more powerful mathematics, is to see these as multiplicative relationships. Each ticket on every means each. Every ticket is $1.25. If we have 3 of them, it's 3 times $1.25, which is $3.75. 4 tickets gives you 4 times $1.25, and therefore 213 tickets, we can do it now rather than with adding. We can see that it's 213 tickets times $1.25 per ticket gives you $266.25, which is our answer. Now, I went all the way to the answer in this particular problem. In order to solve the problem that's asked of us up here, we're really just wanting to interpret slope and y-intercept. We didn't need to come all the way to the answer here to do that. We could have done that right up here. We can see the slope and y-intercept from this. So what are they? What are the slope and the y-intercept? Well, the y-intercept, let's start with that. It's an abstract term that refers to graphing, but what we're talking about physically in the physical world is if the value of the independent variable is 0, we have no tickets sold, what will be the amount of money made? And in this case, it will be 0. So when we look at, if you can think of this as inputs and outputs, that's a little bit easier than independent variable and dependent variable. The input is like the tickets sold, and if we think of the input of 0, what do we get for an output? What's our output? Well, 0 tickets gives us $0, 0 money. So our output, our y-intercept, our starting point, all of those are the same concept, is 0. And that is one of the key qualities of proportionality, is that the y-intercept is 0, or if there's no input, there's no output. How about the slope? Well, the slope is a rate of change, and I'm already starting to interpret it, but the slope is how much does the money change each time that we add a new ticket, that we sell a new ticket. And if you look, each ticket sold results in $1.25 more money. And so the